Let's look at it, and let's see what this one, how this one's different than this one. But does anybody have a question on this one? This is pretty straightforward. Okay, let's read that together. I've got 116 grams of ethanol is needed for a chemical reaction. What volume of liquid would we measure if you knew that the density was 0.789 grams per mil? Well, we just got the density. Densities are also on labels when you first buy the stuff. Why would we want to do a problem like this? Because if you're talking about a liquid, most people think in a real lab it's easier to pour out a volume. You know, a graduated cylinder? Just pour it out in the graduated cylinder and you've got the volume. But if you've got a liquid and you want a mass of it, then you got to find a nice clean beaker, you got to have a good balance, you got to zero it, and then you got to put it in and then in and out and in and out. So, if you know the density and you know the mass you need, but you're too lazy to really go take the mass, it's an extra step or two, let's do paper and pencil here and find out what the volume is we need, and then we'll just pour out a certain volume, and we'll know that volume has a certain number of grams in it without ever walking through an electronic balance. Okay, it's also a good way if you've had a power failure and you're working in there by candlelight, so your electronic balances are worthless, but you can still get it. So you look at that. Okay, the big clue, the word density. As soon as I see that word density, I write this down. Then I'm going to sort through, what do I have this time? How is this problem different than the previous one? Steve, what's the density?
0.789.
Okay. And what are the units, Steve? On a density, that's right up there.
Grams and
Over
millimeters.
mils. You want to carry that along. Okay, now, we want to take a look at it. We know the grams we need, right? Timothy, how many grams do we need?
116.
116 grams, and we want B, and this is the hardest way to go. On the practice quiz, this was the last one. They are similar to this one, where you have to continue. So, this one time, I'm going to take it slow and easy, and I hope I'm boring everybody. Little algebra lesson. Okay, we're solving for V. It's on the bottom here. Okay, if you're solving for V1, you want it up on the top, and you want it standing alone. So we're going to take two steps. We're going to multiply both sides by V. So if I really wrote all this garbage out, I would have this. The V's cancel on that side. Or the down and dirty way to think of it is, if you're dividing on one side, if you whip it across the equal sign, you do the opposite operation. And so right now I've got V times 0.789 grams per mil is equal to 116 grams. So one thing we've accomplished, we got the V up on the top now. Okay, then I want V standing alone to solve for it, so I'm going to divide both sides through. And of course it cancels there. So the down and dirty way, whip it across and you do the opposite operation. So our volume is going to be 116 grams, like so. Okay, now if you do a unit analysis, this is like a complex fraction, isn't it? Grams and grams cancel. Mils are going to come around on the top. You know, if you had 1 over 2 in a math class, this top one is 1 over 1 divided by 1 over 2. Okay, what would you do with this thing? Invert and multiply, right? So the answer for that would be
2.
2. Good. Okay, over here we're really doing the same thing. You got G over grams. Mils are going to come up on the top, so we go, hooray, we got the right units. We want to think sig figs. Andrew, do you have that punch through?
147 milliliters.
147 mils. Okay, did he do us right on the 6? Yeah, great job. Everybody okay on density? Okay, and of course, we're not going to do this, but if you had to solve for mass, that's not really too bad, is it? If you want to solve for mass, you know this, you know this. When you whip that across, you're just going to have density times mass, or pardon me, I said that wrong, density times volume, and that will give you mass. So you should be able to solve it any of those 3 ways. Questions? All right, great. Now, specific gravity. We want to talk about it just kind of briefly because this is what medical people use. And this is always an issue. You know, medical people say cubic centimeters or cc's, and we say mils, but no sweat, we know it's a 1-for-1. So like these densities, 0.789 grams per mil, I want that in grams per cc because I work in a hospital. Marco, what'd you say?
Switch it over. Just
Say
instead of milliliters, say cc, grams per cc.
Okay, so you'd say 0.789 grams per cc or grams per cubic centimeter. It's a direct 1-for-1. So that one's easy. Now, medical people like specific gravity. If you go in for a urinalysis, what's one of the things they're going to do? They're going to tell you the specific gravity of your urine. If you were in a chemistry lab, they would give you the density of your urine. Okay, why are they interested? Okay, pure water has a density of 1.00 grams per mil, right? At normal temperatures. And you probably got close to that, maybe not right on the money, because there's always some experimental error in measurements, but that's similar to what you got in the lab. Well, urine is not pure water. That it's got some stuff dissolved in it, some salts, or if somebody is diseased, they might have some blood in their urine, they could have sugar in their urine. Well, if you got stuff dissolved in the water, then the density is going to be a little bit greater than 1. And so how much greater it is can kind of tell you what's going on with this person. You know, how concentrated is the urine? Are they not drinking enough water or something? So they use specific gravity, and we use density, but here's what it is. Specific gravity is equal to density of your substance divided by density of water. Well, what this means, density of water is 1. So numerically, nothing changes. What happens is the units get trashed. So let's take a look. The next problem here. Okay. And it is on the next page. So let me get that. There's one specific, it's 1-16. 1-18. What now? This is 116. Okay, here's the definition, and then let's move on down. Here's our real problem. We have sodium chloride, just ordinary table salt. And what we find is the density. First, let's get through all the wording here. The first line is just what I have up here on the board. Specific gravity is defined as, and that's exactly what I have here. Really, it's a comparison to pure water. And so, density of water, and that's a number you really should note, 20 degrees Celsius is about room temperature. If I were to guess right now, I'd say it's probably 22 or so in here, so 20 is about room temp. Okay, the density of water is 1. There's our density, and what they're telling us, we look at that, big clue, specific gravity. So we know that. Other big clue in here, density. We know that. And so, it's telling me the density of sodium chloride is 2.16 grams per milliliter. Density of water is always for us, because we're not working at extreme conditions. And you may say, oh, urine, it's not at 20 degrees Celsius, it's at body temperature. Well, yeah, when it first comes out, but the density of water is not going to change that much, at 37 to 20. And the units here are grams per mil. Okay, so Clint, when we work that out, how many SIGs do you want in your answer?
3.
3. What about your units, Clint? What's going to happen to them?
They'll cancel.
They'll cancel. The whole shebang is going to cancel. And so all you have to do, specific gravity is 2.16. Okay, so the bottom line is this. This is what the medical folks like, so we will take a look at it because a lot of you are in pre-health professions. We use density. All you have to remember is if you have density, slap those units on. If you have specific gravity, take those units off. It's the same number. Now, in the past, I've given little quizzes on specific gravity, and I see people grabbing their calculators and doing some horrendous calculation. I don't know what they're doing. So, all you have to do is think on, off with the units. Okay, so that's our specific gravity. Anybody have a question about it? Okay. Also, another place, I think they talk about specific gravity. In old batteries, you used to open up a battery and they would put a hydrometer in it to see what the specific gravity was, because that gave them an indication, is there enough acid in your car battery? Now most batteries, I think, are sealed, so they don't go around doing that kind of stuff. But with acid in the batteries, they used to do that. Okay, so that was section 12. Now, we're ready for our last 2 sections here. When we talk temperature, we're talking intensity of the heat. How does it feel to us? It's not how much heat energy is there. So a lot of people kind of get those two confused. And unfortunately, once again, because you're in this country, we have to deal with an extra temperature unit. So, with my modern art, that is a thermometer. And in this country, we use degrees Fahrenheit to talk about the temperature in our homes or the weather. Like we've heard the bad news, it's going to get down to around 40 degrees Fahrenheit this afternoon. Okay, on the Fahrenheit scale, weird numbers. Where does water freeze on the Fahrenheit scale? 32. 32 degrees Fahrenheit. You had memorized some weird number. Okay. Does anybody know where water boils on the Fahrenheit scale? 212. You have a lot of extra garbage in your brain. Okay, weird numbers. But this is what we use in everyday life. Okay. This used to become the centigrade scale, but now it's kind of shifted over. Everybody calls it Celsius. But luckily, centigrade or Celsius, same letter of the alphabet. Okay, they just redesigned the thermometer here. And, okay, if you got a hollow tube with some mercury in it or some colored alcohol, you can calibrate it any way you want to and make up your own thermometer. So they said, hey, why don't we set this temperature for freezing water? Let's set it at 0. It's a lot easier to remember. And then, let's set the boiling point, the normal boiling point temperature of water at 100 degrees. And then they divided it up 100 ways. Centigrade, centi means 100th of the total difference here. And we base a lot of stuff on water in chemistry just because it's so abundant and it's cheap. Okay, so they just came up with a new scale. What we have to be able to do is to switch back and forth.